Video will cover examples from exam 2 review. Question number 1, perform the operation and write the result in standard form. So I'm going to be doing the problems that are unbolded. And so here for question 1, I'll be working letter B. So here we can rewrite this as 3 plus 2i. I'm going to distribute the negative into the parentheses. So minus 6 minus 13i. Gather your like terms. 3 minus 6 is negative 3. 2i minus 13i is going to be 11i. Okay, number 2, letter D. We're going to be multiplying by the conjugate, 1 plus 2i, to the denominator and the numerator. So here we get 6 minus 7i times 1 plus 2i divided by 1 minus 2i times 1 plus 2i. So if we multiply 6 times 1, we get 6. 6 times 2i is 12i. Negative 7i times 1 is negative 7i. And negative 7i times 2i is negative 14i squared. Divided by, since these are conjugates, I can use the shortcut, which is 1 squared plus 2 squared, since the middle terms will be canceling. So here we can gather our like terms. Remember that I squared is the same as negative 1. So I'm going to have negative 14 times negative 1 is a positive 14 plus 6 gives me 20. And 12i minus 7i is 5i. In the denominator, we have 1 squared is 1, 2 squared is 4, 4 plus 1 is 5. Simplify, 20 divided by 5 is 4, and 5 divided by 5 is 1. Example 3, describe the end behavior of the graph of the polynomial function. So remember here, we use the basic parent functions to remember what these end behaviors are. So this is x squared, negative x squared, x cubed, and negative x cubed. So to find the end behavior, we're looking at the leading coefficient and we're looking at the degree. So in example C, here I have a negative 7/8 in front. So if I was to multiply that, I get negative 7/8 x cubed plus all this other information. Here I'm only interested in the leading coefficient and the degree, so I'm going to go ahead and stop there. So my degree is 3. My leading coefficient is negative 7/8. And so my behavior is going to look like this function. So I can say that the graph rises left and falls right. Example 4, use the rational zero theorem to determine the possible rational zeros of the polynomial function. Do not find the actual zeros. So in order to find the possible zeros, the factors of the constant term, and we want to look at the factors of the leading coefficient. So we're going to call our constant here is going to be the factors. We'll call them P. And our coefficient with the factors, we'll call them Q. So if we divide these, the factors for 45 is going to be plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 9, plus or minus 15, plus or minus 45, divided by plus or minus 1 and plus or minus 2. So if we divide this, our possible zeros will be 1 divided by 1 is 1. 3 divided by 1 is 3. And in the same way, every number in the numerator divided by 1 is going to be itself. Then we start with 2. So 1 divided by 2 is a half. 3 divided by 2 is 3 halves. 5 divided by 2 is 5 halves. 9 divided by 2 is 9 halves. 15 divided by 2 is 15 halves. And 45 halves. So this is our list of possible zeros. Use the graph below to answer the questions. Is the leading coefficient of this polynomial positive or negative? So again, you can refer to these 4 graphs. So if you notice here, the behavior is it's rising to the right and falling to the left. So if we look at our 4 graphs here, rising to the right, falling to the left, that means that the degree is odd. And your leading coefficient is positive. What are the zeros? So the zeros are x equals -5, x equals -4, and x equals 1. What is a y-intercept? Y equals -20. Answer the question below and sketch the graph of the quadratic function. So here, does the graph open up or down? So since we have a negative in front of the x squared, it's going to open down. What are the coordinates of the vertex? So to find the vertex, I can use the formula. So first I'll find x. B is -8, so I'm going to have -8 divided by 2 times a. So negative is +8 divided by -2 is -4. Once you know your x, we're going to plug it into the equation to find y. So we get -4 squared minus 8 times -4 minus 12. So let's simplify. -4 squared is 16 times a negative is -16 plus 32 minus 12. -16 plus 32 is 16 minus 12 is equal to 4. So our vertex is -4 and +4. Find any X intercepts. So one, you can use the quadratic formula, or you can factor, or you can write it in standard form. I'm going to go ahead and try to factor. -x squared minus 8x minus 12. So we have -x times x. 6 times 2. Set our factor is equal to 0. So x is -6 and x is equal to -2. What is the equation of the axis of symmetry? That's always going to be your x coordinate from the vertex. So in this case, -4. And then we're going to sketch the graph. So we have -2 is right here. And then we have -6. We have our y-intercept is 0, -12. Remember, your y-intercept is your constant here. So that's going to be down here. And then our vertex is -4 and 4. So we can sketch our graph. The answer sheet gives you the standard form. So if you want to see how that was done, I'm going to write it here. So here I can separate my polynomial in this way. I'm going to factor out the negative. Take half of 8, which is 4, and then square it so we get 16. So I'm going to add 16 and subtract 16. So we want to factor out this negative 16. However, if I pull out my negative 16, I do have to multiply it times this negative. So that's going to give it a positive 16. So then we're going to have negative. I can write my factors as x plus 4 times x plus 4. And this should be a negative here. So 16 plus negative 12 is a 4. Since these are the same, I can write it as x plus 4 squared plus 4. So this would be your standard form. Number 7, use synthetic division to divide. So here my coefficients are 9, negative 18. Remember, they need to be in order, negative 16 and 32. I'm going to be dividing, in this case, 2. So we bring down the 9. 9 times 2 is 18, minus 18 is 0. Negative 16 times 2 is negative 32. So we get remainder 0. So our quotient is going to be 1 less from the degree. So this would be x squared, 9x squared. There's no x term, minus 16. To write our answer, you want to write down your quotient plus your remainder, in this case 0, divided by your divisor. However, we know here that 0 divided by anything is going to be 0. So we can just enter our answer as this. Number 8, I'm going to go ahead and work out letters C and D. So we want to find the zeros. So the first thing we want to do is set the function equal to 0. Then we can either use the rational zero theorem and find possible zeros, or we can factor out an x squared here, giving us x squared minus 4. So 0 is equal to x squared, and 0 is equal to x squared minus 4. Add the 4 on both sides, take the square root. So x is equal to plus or minus, so x is equal to plus or minus 2. Here, if we take the square root, we get x is 0. So my zeros are x equals 0, x equals 2, and x equals negative 2. However, the degree is 4. I should have 4 zeros, and that extra 0 is going to come from this factor here. Since I have x squared, that produces 2 of the zeros. So at x equals 0, it appears an even number of times. So this is going to have multiplicity of 2, which is even. So the graph is going to touch and turn. And for these, the multiplicity is 1, which is odd. So the graph is going to cross. Let's try letter D. So we set this equal to 0. I'm going to find the possible zeros. So for the factors of P and the factors of Q, so the factors of P are 1, 2, 3, 4, 6, and 12. The factors of Q are 1, that's the leading coefficient. So my possible zeros are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. So we can test these. If I try 1, drop down the 1, 1 times 1 is 1, 3 plus 1 is 4, times 1 is 4. We get 0, negative 12. So that doesn't work. And negative 1 doesn't work. So I'm going to try 2. Drop down the 1. 1 times 2 is 2. 3 plus 2 is 5. Times 2 is 10. We get 6 times 2 is 12. Remainder of 0. So that worked. So our quotient is going to be x squared plus 5x plus 6. So we can set our quotient equal to 0 to find the rest of the zeros. This is going to factor. So 1 0 is going to be x equals negative 3, and the other is x equals negative 2. So my zeros are x equals 3, negative 3, x equals negative 2, and x equals 2. X equals 2 comes from our synthetic division. Question number 9. Okay, so to graph this, we need the end behavior. So since we have even and a negative, the behavior is going to be false right and false left. We need to find the zeros. So I'm going to set my polynomial equal to 0. We can factor out an x squared. And solve for x by setting each factor equal to 0. So here I get x equals 0. It's going to be 2 of them. So my graph is going to touch at x equals 0. Here I get x squared is equal to negative 16. Divide by negative 16, so we get x squared is equal to 16. Take the square root, x is plus or minus 4. So at these zeros, it's going to cross. My y-intercept is 0, 0, since there's no constant here. So if we were to graph, we have our zeros, which are at 4, negative 4, and then x equals 0. The behavior of this is that it's going to cross at this 0 and it's falling, so it's going to go down like this. And then at this 0, it's going to touch and turn. So we can pick additional points. Let's pick 1. So f of 1 is negative times 1 to the 4th plus 16 times 1 squared. So that's going to be negative 1 plus 16, and that's 15. So 15 is going to be up here somewhere. So my graph is going to come this way, and it's going to come back down. It's going to touch here. It's going to come up. So if we pick negative 1, we end up with negative 1 So if we pick -1, then we substitute it into the equation. So we get -1 to the 4th power is +1 times negative is -1. -1 squared is 1 times 16 is 16. So we end up with 15 again. So that's going to be somewhere up here. So we come back up and go down. So that is just a sketch of our graph. Find any vertical, horizontal, or slant asymptotes. So to find the vertical asymptotes, you want to make sure that our numerator is factored and our denominator is factored, and in this case they are. So we set the denominator equal to 0. So my vertical asymptote is at x equals 7. My horizontal asymptote, the degree of the numerator is 1, the degree of the denominator is 1. Therefore, the horizontal asymptote will be the leading coefficient of the numerator, which is 1, divided by the leading coefficient of the denominator, which is 1. So our horizontal asymptote is y equals 1. And there's no slant asymptote since we had a horizontal one. In this problem over here, if we find the vertical asymptotes, remember you want to factor completely. That way we can see it, we can cancel out any factors. Here we cannot factor out any factors. So we set each factor equal to 0. Solve for x. So these are my vertical asymptotes. My horizontal. Notice that the degree of the numerator is 1. The degree of the denominator is 2. Since the degree of the numerator is smaller than the degree of the denominator, then we say that the horizontal asymptote is at y equals 0. And again, there's no slant asymptote since we have a horizontal asymptote. So now we want to graph. So if you notice here, this problem is the same as letter A. So to graph this, you need to know the vertical asymptotes and the horizontal asymptotes. So from our previous work, we know that this has a vertical asymptote at x equals 7, and it has a horizontal asymptote at y equals 1. Next, you want to find, so first we found the vertical asymptotes, then we find the horizontal asymptotes. Next, we're going to find the x-intercepts. So we set the function equal to 0. So we get 0 is equal to x minus 4, because if we multiply by x minus 7 on both sides, this will cancel. X minus 7 times 0 is 0. So x is going to be equal to 4. So this is a 0. The y-intercept, we let x equal 0. So if we plug in 0 for x, we get a 4/7. So that's going to be, so if x is 0, we get 4/7. So this is around right here. So here we can pick some more points. Let's pick a point on this side. So this was 8. So if we plug in 8 into our function, we get 8 minus 4 divided by 8 minus 7. 8 minus 4 is 4. 8 minus 7 is 1. So we get a 4. So that's going to be here. You can pick another one if you wanted to. So we pick 9. We get 9 minus 4 is 5. 9 minus 7 is 2. So we get 5/2, which is 2.5. So about right here. So we know how these type of graphs behave. So my graph is going to come down here and go down here. And then for this side, it's going to get close to the asymptotes. And then it's going to go this way. So it's not going to touch the asymptote. So let me redraw that. And so that would be our